Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Shazni binti Muhammad Suyud. My student ID is 2019406258.
My name is Alifah Ilyana binti Muhammad Zaidun. I am from Group 7. My student ID is 2019607818.
My name is Muhammad Al-Amin bin Muhammad Fidaus. My student ID number is 209883332.
Hi, my name is Wan Nushazwani binti Wan Hanafi. My matrix number is 2019685986.
The objectives of this experiment is firstly to demonstrate the free and forced vortex experiment, secondly to compare the surface profile for free and forced vortex, and lastly is to investigate the natural phenomena associated with free vortex. Vortices may occur spontaneously or be demonstrated in a lab. There are two types of vortices, free vortices and forced vortices. A free vortex is formed, for example, when water flows out of a vessel through a central hole in the base. No external force is required to rotate the fluid, and the degree of rotations dependent upon the initial disturbance. Whirlpools in rivers and tornadoes are few examples of natural free vortices. A forced vortex, on the other hand, is caused by external forces on the fluid. It can be created by rotating vessel containing fluid or by pedaling the fluid. Rotational flow created by impellers of a pump is an example of a forced vortex in turbo machinery.
And now for the theory. Vortex is a region where fluids start to flow around a curved or straight axis. Vortices can occur naturally or by force. There are two types of vortex, free vortex and forced vortex. These pictures are the surface profile of free vortex and forced vortex. Free vortex. Free vortex is a vortex that forms when water flows out of a vessel through a hole that is at the center of the vessel. There are no external torque and energy required for free vortex. The Bernoulli equation can be applied, and the degree of rotation depends on the initial disturbance. Velocity is inversely proportional with the distance from the axis rotation. Thus, we got the equation V equal K over R. Derived from Bernoulli equation, we got V squared over 2G plus Z equal to C. Combine the equations, we can get K squared over 2GR squared plus Z over equal to C. And from this equation, we can get the height of the surface of the vortex that we want from the base of the vessel. For forced vortex, fluid is rotated about a vertical axis and external energy or torque is needed to maintain this flow. All fluid particles rotate at a constant angular velocity as a solid body. When water rotates at a constant speed, the velocity will be constant, thus we get the equation V equal WR. The velocity head hc is equal to V squared over 2G. Combining the two equations, we got hc equal to R squared W squared over 2G. If the horizontal plane passing through the lowest point, the total energy is H equal to H naught plus Hc, where H naught is the pressure head at the datum. When we combine this equation from the previous one, we got H equal to H naught plus R squared W squared over 2G. At R0, H0, H naught is 0. Thus, we got the final equation H equal to R squared W squared over 2G.
Firstly, prepare a water bottle with diameter of 1.0 cm. Then, fill in the bottle with about 750 ml of water. Then, place the bottle on top of another bottle to make it easier for us to observe and measure the vortex. Measure the diameter of the vortex and the height of the water from the datum when the vortex started to form. Then, repeat the process with different diameter of the bottle.
Prepare a bottle with diameter of 0.5 cm. Fill in the bottle with 700 ml water. Stir the water using a chopstick for about 40 revolutions and record the time taken. Place the bottle on top of another empty bottle. Measure the diameter of the vortex and the height of the water from datum when the vortex started to form. Repeat the process with bottle with different diameter.
Next is the results and data. These are the data for our free vortex experiment. As you can see, we repeated the experiment 3 times with different diameter of water outlet. 0.5 centimeters, 1 centimeters, and 1.5 centimeters. The vortex diameter and the height of water level from datum are as shown from the table. And the observation from the experiment, for the 0.5 centimeters, we observe low flow speed with small size vortex. For the 1 centimeters, we observe medium flow speed with medium size vortex. And for the 1.5 centimeters diameter of water outlet, we observe fast flow speed with big size vortex. And these are the vortex profile for the experiment. This is for the 0.5 centimeters, 1 centimeters, and 1.5 centimeters.
Result of force vortex. For the force vortex result, we also use the same diameter of outlet water, which are 0.5 cm, 1.0 cm, and 1.5 cm. The number of revolutions that we use is 40. Diameter of the vortex, height of water level, and time taken to complete the revolution collected from the experiment is simulated here.
This is a graph that shows the surface profile for force vortex. This is the surface profile for diameter outlet water 0.5 cm. This is the surface profile for diameter outlet water 1.0 cm. And this is surface profile for diameter outlet water 1.5 cm. However, the surface profile for the force vortex in this experiment is a bit different with the theoretical surface profile due to some of the errors occurred while doing this experiment. Discussion. These experiments were performed to demonstrate the free vortex and force vortex surface profiles of the vortex and the relationship between free and force vortex velocity and angular velocity respectively. In order to determine the relationship between the velocity and angular velocity for both free and force vortex, the fluid mass for the free vortex rotates without external force only through internal action. Meanwhile, force vortex rotates by a constant torque exerted by some external source onto the fluid mass. For experiment of free vortex, an observation of vortex surface profiles was performed. In this experiment, 3 different sizes of diameter were used, which are 0.5 cm, 1.0 cm, and 1.5 cm. For the diameter 0.5 cm, the vortex form was in smaller water surface profile. For the second diameter, which is 1.0 cm, the vortex form was much larger than the vortex formed by 0.5 cm diameter. The use of diameter in 1.5 cm was the largest vortex form. From the experiment, when the size of diameter get larger, then the vortex form will large too. This causes a drop in elevation since pressure is the same on the free surface. For the experiment of force vortex, a chopstick was used to create force vortex. The surface profile of force vortex is a parabolic shape. For this experiment, we use 40 as a number of revolutions. Due to the obvious type of parabolic form, the angular velocity of the water in the bottle increases as the dip of each pointer at different vortex radius also increases. The velocity increases in each diameter as the diameter of the vortex increases. However, the surface profile for the force vortex in this experiment is a bit different with the theoretical surface profile due to some of the error occurred while doing this experiment. Cyclone separator is one of the applications used in the industry based on force vortex behavior. Cyclonic separation is a method of removing particles from an air, gas or liquid stream without the use of filters through vortex separation.